Hi, so I'm just going to walk through some of the PySpark code in the Jupyter Notebook. And so here what we're starting off doing is just starting up the Spark uh, application. And then we're going to import some packages, um, including for column kind of manipulation as well as some other kind of functions from the PySpark SQL module. And then we're going to import some of these functions for fitting certain types of models and evaluating them, uh, cross validation, and then establishing a pipeline. Um, I've also gone ahead and installed some Python libraries, including pandas and matplotlib and seaborn for data visualization. So there aren't great tools for PySpark data visualization as far as I know. And so you can import these in to visualize the data in the notebook. And then you can go ahead and import in other libraries that you might be interested in. So I had Conda installed these packages earlier and just tested to see that they worked in the notebook. So next we're going to kind of ingest the data. And so that can be done in a variety of ways. Um, so here, one way is to read it into a pandas data frame and then convert that data frame into a Spark data frame. That's one method. Um, uh, Another method is if you have your data sitting in an S3 bucket, which some of this benchmark data for MoleculeNet is, you can directly import it from S3 really easily. Another way is if you have the URL, you should be able to do it using Spark files, which I haven't done, but is another option as well. Once you have the data in, here I'm creating using the pandas data frames to create a Spark data frame. And so this first data frame incorporates the standard featurizations in the base data set. In the second data frame here, what I've gone ahead and done is add in another set of 300 features using Multivec. And Multivec is a unsupervised machine learning approach. And so let's drop this over here. And so in this paper, they basically train this model for recognizing chemical substructures and embedding it in a vector. And so this model can learn kind of a representation of the data using just the smiles. And so I've run that model on the smiles in the base data set to see if it can improve our prediction. Um, and so that second data frame will have those additional Multivec generated features. What we're doing next is actually doing some pre-processing on the column names. And so we'll run into issues kind of later down the road if we don't change this now. And basically what we're doing is we're removing the periods and the parentheses from the column names and just replacing them with either nothing or an underscore. And that'll allow us to proceed more smoothly in the next steps. And so here, in this step, we're generating a pipeline. And so this is very standard for a Spark analysis. And this pipeline basically is a linked set of functions or operations that you can run on the Spark data frame. And then you can do that, you can run that multiple times across multiple data sets. And so what we have here in this kind of columnar data with just numerical data is we're using the vector assembler. And so the vector assembler is going to take all the features in the data frame and compress it into one column. And so that one column will be called pre-scaled. And so a lot of the PySpark functions operate on generating a model from a single column. And so this vector assembler puts it all into that one column for downstream model fitting and analysis. And so once we establish that column, what we're going to do is just some standard standardization. And so we're going to take that pre-scaled column and then output a new column called features, which is going to have zero mean and univariance. Um, and so yeah, that final column that we'll be working with is called features now. And so this is convenient because a lot of the downstream model fitting, the default for the features column is called features, and so that fits in nicely there. And then here now we're just declaring these as part of the pipeline. So these are the stages of the pipeline, and we're calling it pipeline one, and then we can use it to fit and transform the data. And so here we're taking that pipeline and fitting it on that data frame, and then transforming it and returning a new data frame, which we'll call scaled. We're doing the same one with the Moltevec data frame, which is slightly larger, and so it requires like a different assembler, but uses the same scaling procedures. And so, yeah, now we'll have two scaled data frames. What we want to do next is train, test, and split the data. There are a lot of ways to do this in PySpark. One way is to use the random split method on the PySpark data frame. You can also do, there's a function where you can do a train validation split. This data set already has a column labeled model that kind of specifies what to use as training, test, and validation. And so I've kind of leaned on that to develop the model. Um, and so, yeah, I'm just splitting the data for both data frames into these training, testing, and validation sets. And so that leaves us with roughly 1,300 rows to train on. And in the standard data frame, we'll have roughly, I think it's like 590 features.